So I'm Michael Cubeddu. I'm the co-founder and VP of Research and Development at Aliro QUANTUM. And today I'll be talking about our involvement in the quantum network testbed space. So I'll start with some breaking news from this morning that the EPB quantum network powered by Cubeddu has selected AliroNet to provide the quantum network control and orchestration. So this is very exciting news, and it's been awesome working with EPB and Cubeddu on this project. And yeah, looking forward to some awesome demos for the plenary. I'd like to give a little snapshot of the other amazing quantum network testbed initiatives in the US and in Canada. As you can see here, some testbeds that already exist and are up and running, and others that have been announced or are currently being built. Of course, this isn't comprehensive. There's heavy university involvement in the space as well. And I'd like to highlight also the heavy US agency involvement as well. A lot of the DOE national labs and NIST, of course, as you heard from Thomas, and other agencies as well, really getting involved in the space. So it's a very exciting time for the field. So how Aliro fits into the ecosystem here. So we've designed a solution called AliroNet that allows us to work with a lot of these organizations, regardless of where they are on their quantum networking journey. So we've modeled our solution in the AliroNet to support what we call the 3 stages of quantum network development, from stage 1 of quantum network testbed design and emulation to actually implementing these testbeds, small scale pilots and trial networks consisting of maybe a handful of nodes across a campus or metro scale, then ultimately, scaling up from there to a full scale deployment. So kind of double clicking on AliroNet, I'll talk about some of the underpinning software products that are provided. So first, we'll start with the Aliro simulator. This is a full stack quantum network simulation tool that goes all the way down to the nitty-gritty physics simulations for individual components that you typically see in these kinds of networks, but also modeling of the fiber and other channels, simulation of the high resolution timing, down to arbitrary precision, which is very important. But also not just the physical layer simulation, also simulating protocols and applications, so we can make design choices on what pieces of hardware we would want to build into this network and how that network can be used for certain applications. Next up, we have the orchestrator. So this is the touch point for the network. So this is where end users will actually configure the network, schedule experiments, and define any performance metrics they may need for their application, and they can schedule their experiment. Additionally, it also has an operator interface. So this is important for the network owners for doing things like network management, network monitoring, managing access to different resources on the network, things like that. And when it's time for an application to actually run on the network, that's when these runtime software components come into play. So we have the Aliro controller, which manages instances of what we call Aliros, which is our operating system that does control protocols for entanglement generation, entanglement distribution, and other control protocols necessary for this quantum network testbed. So as we work with many of these organizations building their testbeds, of course, many of them are at different stages in their journey. Some are just getting started. Some are still planning out exactly what they want to build. But these considerations tend to pop up front of mind. So I thought I'd give a little bit of a user perspective for these testbeds. So the first box is who. So who are the intended users of this network? What are their common needs and use cases? Is this an open network? Is this a closed system that's going to be used internally? Who's going to manage and maintain the network? Who are the appropriate partners and collaborators and stakeholders for this network? Then we have the what's. So what are the objectives of this quantum network testbed? Is this to be offered as a service? Is this commercial? Is this for research? So what are the objectives of this project? And based on that, what performance metrics do we need to meet? What distances do we want to support? And in turn, what hardware do we need to enable all of those things? Additionally, are there any other imposed constraints like budgetary constraints, timeline constraints, things like that? And finally, how? So how are users going to actually access this network? How am I going to manage access to this hardware and time on the network, things like that? How is this going to integrate with the rest of my classical systems? And how is this network going to mature over time? What's the roadmap? So these are some of the common considerations that we have in discussions with a lot of these organizations building out these test beds. So I figured it would be important to highlight those. And I'd like to end with an analog to the classical internet. And so we're seeing similar trends here in the development of the quantum internet, which is very exciting. Forgive me for the low resolution. This is probably a fax from the 70s. So, but we see a similar trajectory with ARPANET, with the quantum internet. But I'd like to really hammer home the point that testbeds are extremely important towards this end goal we all have and we all share for the quantum internet. So from the hardware perspective, testbeds are awesome for developing new pieces of hardware and better hardware, for testing device interoperability from different vendors. And then from the software perspective, testing out software integrations, developing new protocols and optimization techniques for these networks, and for testing new applications that we maybe haven't thought of yet. And of course, all the great benefits we get from building out these testbeds, standards development, workforce development, and providing a path to scale as we begin to interconnect these networks. So that's it. I'd like to end with a comment that AliroNet was built to design these quantum network testbeds, to build them, and ultimately to scale them and deploy them. So regardless of where you are at on your quantum networking journey, we're eager to work with you, and please reach out.